So this talk is for Mickey. He knows somebody who is a geologist. I should have you know, Mickey, I've taken geology at University of Maryland, and I've also read a lot of books in geology, and I can see some major assumptions they make about the world around them that sort of skew their ability to observe objectively. This paper here is an open correction to James Hutton's famous quote concerning Uniformitarianism, big word there, as first principle. Basically, when James Hutton was around, this is 1795, when he wrote The Theory of the Earth, he says, quote, "We find no vestige of a beginning, no prospect of an end." So he pushes the Earth as being just this timeless, deep time type of object where you can't really tell how it was formed, what it looked like when it was forming, or you can't tell what it's going to become because it's just so old, it's so ancient. James Hutton, the father of modern geology, supported the concept of deep time by making observations of the Earth's geological features. His outstanding observations are to this day incredibly important for the continual study of geology and for the future wellness and wholesomeness of the sciences. He was ridiculed for proposing such enormous intervals of time needed to form the features of the Earth, well in excess of 6,000 years per the biblical creation account. Nonetheless, a specific feature of his deep time argument was not complete, and can be given a more wholesome approach due to overwhelming observational evidence provided by modern astronomy. And I have to elaborate that modern astronomy has 2019 here. We're talking 1795 when James Hutton, so there is a big gap of time here. Lots of technology has changed. In effect, we can see what the Earth looked like and can tell what its main features resembled by observing the stars in the night sky at all wavelengths. We can also tell what the Earth will look like long after all its heat and energy life has dissipated back into space. These two approaches extend his original deep time proposition vastly beyond both the Earth's assumed beginnings and far beyond its ends, which have yet to be imagined by current astronomers and geologists. Some of them are emailing me. I don't want to name drop them. This all means we cannot only propose the Earth is old by assuming it has always remained more or less in its current configuration, but that it has had enormously different characteristics and will almost completely disintegrate back into the universe. Deep time itself can go even deeper by looking up, not just down at the rocks in the ground. Okay. This statement alludes to the idea, this is the Vestige statement. This statement alludes to the idea that Earth's earliest beginnings do not have observational evidence for, as well we also do not have observational evidence for its end. This, of course, is to be expected in a time where people believed the Earth to be 6,000 years old, and astronomy itself was still accepting the Milky Way as the entire universe as a whole. So we have to put ourselves in his shoes and not be too harsh. You got to be kind to him. He was alive over 200 years ago. He was correct that just observing the Earth as a standalone construct by studying the rocks themselves, there can be no vestige of a beginning. Their histories of forming and deforming, leaving crustal remains to be explored and explained, but clearly this does nothing to explain how they became rocks, or even molecular combinations of crystalline structure from the very beginning. As well, there is no end to rocks, as they are inanimate structures, ready for weathering and disintegration, so they cannot end as much as they cannot die as a living creature can. So he hit a dead end, but was wholly fine with drawing up an already unimaginable and true conclusions, as the processes that formed them took many millions of years. Thus, the whole deep time concept, where what is needed to make the Earth as it is, was at least millions of years. Luckily for us, we have astronomy to make this concept of deep time go even deeper into the abyss. From that, we must wisely interpret the heavens themselves and draw conclusions from them. In fact, we actually do have a vestige of a beginning for Earth and ending prospects. These are two completely different things that James Hutton did not have. He had the deep time thing down, but the deep time thing was kind of in a box. He didn't have the beginning of the Earth and he didn't have the end. They are the stars themselves, though what geologists must do is give a sort of reckless abandon to the uniform first principle of Hutton, which stems from the idea the Earth cannot have its beginnings or endings observed. And he is partially correct. I'm not going to read the rest of this. He's partially correct. Earth cannot have its beginnings observed. I mean, the actual formation of the crust itself, what geologists study, cannot be observed from the very beginning, because that process happens internal to the star. And the star has a very, 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 very large atmosphere, and the characteristics of the star are very different very early on in the Earth's history. There's lots of hydrogen there, and it's bright and shining. I mean, when you look at the sun, that's a very young Earth. Jupiter is intermediate aged Earth. Neptune, Uranus, bit older, pre-ocean worlds. And then you have ocean worlds where they're going to be covered in deep water oceans, and then eventually the oceans are going to dissipate, and then boom, you have your crust and your magma interior and all that. So from a geologist standpoint, and I know this because I've taken geology, I mentioned that earlier in this talk, they look at the crust as being the end-all be-all. Somehow the crust is some type of conveyor belt which is constantly recycling itself and has been doing that for billions of years. But that's not a very good approach, because we have observations of stars that are very, very young, as well stars that are very, very old, and that have completely been disintegrated and broken up into bits and pieces. So basically 3 things here. Astronomers, for instance, they say that they can observe planets being formed. That's false. Nobody can actually see a planet forming because it happens internal to the star as it evolves into gas giant stages and a lot more evolved stages. So if you ever see astronomers saying, we're seeing planets forming, you know they're full of it. Number 2, it's internal to the star. You can't actually see the actual crust forming, but you can see the outer areas, the outer regions, the outer atmosphere of a star, and maybe peer into it with radio waves and microwave to see how the atmosphere is differentiated as it differentiates per the stage in the star's evolution. So, and then you have also other types of measurements, like measuring the magnetic field. It's total angular momentum. It's what would that be? Which is, derivative of the moment of inertia, and a lot of other factors. The elemental composition of the atmosphere, and how much chemistry is happening inside that high atmosphere. All that stuff. You can measure that stuff, but to go down into the very deepest regions of the star to actually observe the planet forming in its interior, I don't think we're that technologically capable yet. But maybe we might get there one day to go all the way into the interior of a gas giant such as Jupiter. You would have to have some pretty badass technology to withstand those kinds of pressures. I'm sure we'll eventually get there. As well, astronomers have made the major mistake, and which obviously kind of puts a gatekeeping effect on the geologists, is because astronomers call the youngest Earth stars and gas giants and brown dwarfs. But those are not independent objects. Those are very young Earths in various stages of their evolution. And the astronomers, they would know this if they could peer deep into their interior to see the planet forming in its interior. But obviously, again, our technology isn't that capable yet. That's why we need theories like this to be able to explain what happens. That way we can look at the Earth's crust and reverse engineer the properties of the Earth and what we see on the surface through geology. Then we can determine how much or what stages the Earth had to have gone through in order to build the features that we observe on the Earth through seismic waves, through drilling, through reason for the most part. And that's what Hutton really needed to know, because Hutton didn't know that the Earth had a very large iron-nickel core. Hutton didn't know about all the evolving objects that are all different sizes around in other star systems. Hutton didn't know, he didn't know a lot. And as well, we also think we know certain things now in the 21st century, which are completely false, being that this new understanding is coming around. So now we have the double effect of learning new information and tossing out dogma that's been around for about 100 years, which is, is the fusion model of stars and the Big Bang and all that other crap, the nebula hypothesis, all that stuff needs to go in order to make way for this new understanding. So all in all, James Hutton was definitely on the right track. And another thought here is to keep in mind that we're taking the next step. It isn't 6,000 years to 4.5 billion years or 10 billion years for the age of the Earth, and then that's it. No, it extends into the trillions of years, and then maybe even quadrillions of years. So it's best to take deep time and take it to its extreme, and kind of look past even the modern young Earth creationists, which are the Big Bang creationists. It's just a rehashing of the same idea that somehow that the entire universe just had a creation moment. I don't think that's reasonable, because we have objects that are trillions of years old in our solar system even. So to say all of existence is 13.7 when we have objects that are trillions of years, it doesn't make any sense. So I'm taking it from James Hutton's level to a whole new level, to where it's like, how can you even imagine timescales of this magnitude? And not only does it put us in size perspective, our physical size, but in time perspective, 100 years for human life isn't even anything. It's not even a blink. It's just an ephemeral. Anyways, I'll link this to the bottom of the page. Hopefully people can understand this later.